Up next, we have the antagonist, which we can have competitive and non-competitive antagonist. Now, for the competitive, all it does is basically just block the receptor. Now, for example, norepinephrine is this receptor's agonist, but it took phentolamine. Phentolamine will come here and block the receptor, not allowing norepinephrine to bind to the receptor. So, norepinephrine has no effect on the receptor because it cannot bind. But the thing is, if you give a lot of norepinephrine, you can eventually displace this phentolamine and make sure norepinephrine can have its effects. For example, this is a normal graph for the agonist if there's an antagonist. But what is an antagonist? You need to give a bigger dose to get your effects. So you now have a large EC50. Remember this graph, dose response relationship? We said increasing EC50 means a reduced potency. A competitive antagonist reduces the potency of a drug. Now for non-competitive antagonists, what does it do? Unlike a competitive that blocks the receptor, this doesn't block it. It binds to an allosteric site. This is the main site, but it's binding to an allosteric site. So let's zoom in a bit. This is the receptor. Phenobenzamine binds to the allosteric sites. It causes a change in the structure of this receptor. Let's say it makes it like this. A epinephrine that could enter here before now can no longer enter this place. So it can bind to the receptor. Now, what's the difference between this and this in terms of action? When this reduced potency, because with increase of the dose, you can give it your maximal effect. With this, no matter how much you increase the dose, you won't get maximal effects. You always get a reduced effect. So your AC50 still remains the same, but you can never get maximal effects. And as such, when this reduced the potency of the drug, this reduced the efficacy of the drug, as you can see from our last video, where there's a difference in efficacy. Now, there's a difference between an antagonist and an inverse agonist. An inverse agonist will take the receptor below its baseline activity, but an antagonist doesn't affect baseline activity. It just stops the agonist from working. But the inverse agonist will take it below baseline activity.